Welcome to the first flipped class of the year. Let's see how this works. We're going to be starting with Chapter 3, Quadratic Functions. A few terms that we got to memorize or remember from last year. General form, y equals x squared plus bx plus c. A is the leading coefficient. Talk about that in a minute. The vertex form for a quadratic function, where the vertex is h comma k. Switch the sign on the number inside the parentheses to get the x value of the vertex. Keep the sign of the number outside to get the y value of the vertex. And that's where you get the coordinates. Okay. The vertex is also called the turning point. The y value of the vertex is either going to be the maximum or the minimum value of the quadratic function. There is a maximum value if the parabola opens down. There would be a minimum if the parabola opens up. Down here is the minimum value, and the minimum value is a y value, as is the maximum value. All right. The axis of symmetry is the imaginary line that bisects the parabola. So that imaginary line, in this case, it would be x equals for a vertical line. It's x equals 4 in this case. Okay. When we do application questions, the axis of symmetry value is the time that it takes an object to reach its maximum height. The zeros of a function are where the graph crosses the x-intercept, or it crosses the x-axis. They are the values of x that make the function equal 0. So whatever the x-intercept is, those are the zeros of the function. Okay? The word concavity, related to concave and convex, if you will, if you remember that from lenses. Concavity is when a graph bends. It could be a nice parabola, okay? Or you could just have maybe some type of exponential type curve. There are two types of concavity: concave up, which means the graph is going to open in an upward direction. And it's easier to see that with parabolas. And we also have concave down, where the graph opens like an upside down parabola, okay? Or maybe something along the lines of a logarithmic function. So those are just some introductory terms for Chapter 3, Quadratic Functions. They're all terms that you should know, should be familiar with. Okay, so onward and upward. So we just mentioned the zeros of a function are the x-intercepts on a graph. Okay. Now, what does the 3 represent in the function up here? Anytime you have a constant in this quadratic function, that constant at the end is going to be the y-intercept. Okay, that is the height when the ball was hit. So think of it this way: the batter hits the ball. The ball was 3 feet off the ground when the bat made contact, and it started to rise. Okay, so right here, the height is 3 at time 0. All right. Now, what was the maximum height that the ball reached? That is obviously up here. Use the scale along the side. So if the second line is 10, we're counting by 5s, 5, 10, 15, 20, 25, 30. And it looks like the ball gets up to somewhere between 37 to 38 feet. And there are ways to calculate that exact value, but we'll get to that later. But as you can see, the ball reaches somewhere around 37, 38 feet. All right. That is just using the graph, kind of estimating what we got. All right. Now, how long did it take to reach the time? That's a time value. So we're going to look at how long it took to reach the maximum height. So it looks like, again, somewhere here, we're just estimating without finding exact values, somewhere around 1.5 seconds. Okay. And again, using the method we'll look at later, we'll find out that it's not exactly 1.5, but for all intents and purposes, it's pretty close to 1.5 right now. Now, how long was the ball in the air? It's in the air until the height is 0. So when it gets down here, the ball is no longer in the air because the height is 0. So this is around 3 seconds. So the ball was in the air for roughly 3 seconds. Okay. Again, not exact, but pretty close. Now, the visible zero in this function is where we can see the graph cross the x-axis, okay? This isn't a technical term, it's just something I made up. The visible zero is where you can actually see it. There's another zero over here, if you extend the graph, it would cross the x-axis somewhere on the left. We don't need that because that's a negative time, which we don't deal with, okay? So the visible zero of this function tells you how long the ball was in the air. Okay? Alright, so now let's get on to finding the zeros of a function algebraically. And the quadratic formula should be drilled into your head at this point. X equals, and again, X is just the arbitrary variable that we're using here. It could be any variable. Whatever's in the equation is what you're going to use. If it's h of t, you would use t equals. Okay? X equals negative b plus or minus square root. Put the b value in parentheses in case it's negative so that you don't mess it up when you enter it in the calculator. Minus 4ac, everything on the right side divided by 2a, something you should know at this point. Now, to find the zeros algebraically, you're just going to use x equals negative b plus or minus square root b squared minus 4ac all over 2a.